Okay, so today we are recapping loci and regions. We're looking at the four main loci. The first one, how do you find a locus that is equidistant around a point? Well, that's just this shape over here, this line over here. Every point along that line is the exact same distance away from the blue spot. Okay, and so obviously that's going to be a circle, because that's what a circle is. A circle is a series of points, connected points, where each point is equidistant from the center. Okay, so for example, that could be a mobile phone signal tower. This could be the radius of the signal, and that's the region that gets signal from the mobile phone. So if you're asked to shade that region, you just shade in the circle. Anywhere within, say if this is 5 miles, anywhere within 5 miles would get signal from that mast. So that's how it would become a region in a problem question. Okay, equidistant around a line. So we need a locus of points where every point is the exact same distance away from this line over here. Okay, so the first bit goes like this. Then it swings around, and then it swings around again. And the mistake students often make is they think that this is going to be a rectangular locus. Actually, this line is the same distance away from the line we're working with here. And then when it gets to the edge here, we've got to keep the locus equidistant from the line, which is now going to be the edge of the line. So it has to stay equidistant from this line. So it kind of swings around that edge. So for example, if this was 5 centimeters, we'd have to do a semicircle where each point is 5 centimeters away from this edge here. So this distance would be 5 centimeters, and that distance would be 5 centimeters. And then it swings around. When it gets back here, it's now a straight line because the line itself is straight. So this is 5 centimeters, this is 5 centimeters, and so on. Equidistant between 2 points. Okay, now for example, this could be some rocks, and that could be some more rocks, and a ship has to sail exactly between those 2 rocks, keep as far away as possible. It doesn't want to go off in that direction, it doesn't want to go off in that direction. It wants to keep the same distance away from both of those points. It's important that you notice that it's equidistant from 2 points and not equidistant from 2 lines, which is coming up next. Okay, so the construction for that is a perpendicular bisector, which is an arc, another arc, a line going through where those 2 arcs intersect. Okay, so we're putting our compass point on point A, drawing this arc, although we've broken up the arc, there's no middle, that's fine as well. Putting the compass on point B, drawing this arc here, although again we've left the middle space out. Okay, and when you're doing constructions, you're always looking for intersections of lines, and you're joining up those intersections of lines, and this is the locus we have. So let's test that. Let's take a point on the line. Yes, that point is equidistant from A and B. Let's take another point. Yes, again, that point over there is equidistant from A and from B, so we know that our locus is correct. You can do that for any point along this line, going on infinitely, actually. Okay, this is the different one to the equidistant from 2 points. It's equidistant from 2 lines. Okay, so what we need here is we need an angle bisector. So for example, this could be one road, a row of houses. This could be another row of houses, and we need for example, a water pipe to be exactly halfway between the 2 rows of houses so that it serves both of those rows of houses equally. So the angle bisector, you put the point of your compass here, you draw an arc, you put the point of your compass here where that arc intersects with the line, you draw another arc, you put the point of your compass here, you draw a third arc, you go from that corner of the angle through where the two arcs intersect each other. That is an angle bisector, and what you'll notice is that this line is equidistant from this line and from that line. And let's try that out. Let's pick a point. Yes, this point is equidistant from both of the lines. Pick another point. Yes, this point is equidistant from both of those lines. And that goes for any point along this locus going on infinitely. Any point is going to be the same distance from both of the lines. So make sure you differentiate between a locus that's equidistant from 2 points, which is this one, and a locus that's equidistant from 2 lines, which is this one. Okay, thank you very much and good luck.